Okay, so in this video, I'm going to demonstrate how to use the second set of orthogonal contrast codes that we created and run them in jamovi. So in the previous video, I just demonstrated how to run the first set of orthogonal contrast codes in jamovi, so now I'm going to do the second set. So like the first set that we tested, we're going to use regression. So we're going to click on regression, go to linear regression. Okay, so here's jamovi getting it ready. So here we're going to put the dv into the dependent variables box. And then we want to make sure we're testing our second set, or the codes we created for our second scenario. So let's go back to our Google Sheets. So this is the set of contrast codes we're going to test. So in this scenario, our primary hypothesis is that groups 3 and 4 will have significantly higher scores on the DV compared to groups 1 and 2. And that's tested in our first contrast code. This one is testing our primary research hypothesis. These other two codes were just created to ensure that we have a full set of orthogonal contrast codes, but they're not necessarily testing questions that we're particularly interested in this scenario. Okay, so let's make sure we're going to test these codes. Okay, so let's go back to jamovi. So these codes are actually right here. Okay, so this is our second set of orthogonal fractional contrast codes. So let's bring these over into the covariates box. And then like the first analysis, let's go ahead and get some information. Let's go ahead and get collinearity statistics under assumption checks. Under model fit, let's get f-test. And then under model coefficients, let's get ANOVA, this 95% confidence interval, and then the standardized estimate. Okay, so here is our analysis using our second set of orthogonal fractional contrast codes. So let's take a look here. So if we go back to that first ANOVA we ran, let's just remind ourselves. So this was that omnibus ANOVA we ran. It was a 3 degree of freedom test. We had an F of 3.866, a p-value of 0.013, and a partial eta squared of 0.139. So what I've been saying is that if we create our orthogonal fractional contrast codes correctly and create a full set, we will run an analysis that's statistically equivalent to this one-way ANOVA. All right, so I demonstrated that with the first set of orthogonal contrast codes. So let's just double check with the second set. So let's keep these numbers in mind. Go all the way down. And we could see that again, this recreates the omnibus test. So this just gives us confidence that what we're doing is statistically equivalent to the one-way ANOVA, which should give us a little bit more comfort, that what we're doing isn't completely wrong. So it's the same exact F. There's our 3 degrees of freedom. P-value is the same. And the R squared matches the partial eta squared from the ANOVA. Okay, so that's nice. That's just to kind of confirm that our set of orthogonal contrast codes is essentially kind of reproducing the mean squared error. That's kind of what we're interested in. So the mean squared error, 12.822, 12.822, and our using this first set. Is it even on this output? Yeah, so 12.822. So that's really the important part, is we want to make sure that we are recreating the mean squared error value. Okay, so we're dealing with the same variability here. Okay. So let's see. So with this set of contrast codes, our primary question was comparing the means for group 3 and 4 as a set compared to the mean of group 1 and 2 as a set. So that's tested in this first contrast code right here. And we could actually see that that's statistically significant. So that's consistent with our hypothesis. And we know that group 3 and group 4 are higher than group 1 and group 2. You could see that from this graph maybe, that the mean of these two dots is going to be significantly greater than the mean of these two dots. The other place you can look is to just double check and see that this parameter estimate for this code ends up giving us our mean difference between the groups. So the mean of group 3 and group 4 is 2.501 points higher than the mean on our DV for group 1 and group 2. Okay, so we made them fractional so that these values produce the entire mean difference between the groups that we are comparing. So the other two codes that we created, again, these aren't testing our primary research hypothesis, but this is kind of what people would end up doing, I think, in papers. Is to say, oh, group 3 and group 4 is higher than group 1 and group 2, and there's no difference between group 4 and group 3, and no difference between group 2 and group 1, right? They're within those groups, they're not statistically significantly different from each other. This would be more exploratory stuff. This was our primary research hypothesis. And again, using these orthogonal fractional contrast codes, we could test our primary hypothesis right away. We don't need to go through some omnibus test first to get there. Okay, and let's just double check that these codes are orthogonal. So when we looked at the codes we created for scenario 1, we saw that they were orthogonal because they were 100% tolerant of each other. So let's double check that here, and yes, these codes are also orthogonal. The tolerance levels are 1, meaning that these codes are completely independent of each other. They're not related to each other. That's what we mean when we say that they are orthogonal. And we did that on purpose. We spent a lot of time going through the steps to make sure that they were orthogonal, so this should not be surprising. It is nice to double check, though, because if you think you're dealing with a set of orthogonal contrast codes and you come down here and the tolerance values are low and they're kind of all over the place, that's kind of an indicator that you've likely done something wrong. Another indicator that you've done something wrong is that if these values here don't match the one-way ANOVA, or the mean squared error doesn't match the mean squared error from the one-way ANOVA, you know you've done something wrong. Okay, so that is this is the end of the series of videos. Hopefully you see the utility of using orthogonal fractional contrast codes to test your variables, to test your hypotheses, and hopefully now you kind of understand the step-by-step process for doing it as well.